Hi, welcome to this video. In today's video, I'm going to do a very nice problem of Russian Mathematical Olympiad of 1945. Okay, we have this inequality, we have this sequence. I'm going to prove this sequence, which is 1 over n plus 1 plus 1 over n plus 2, and so on and so forth, all the way down until you get the last term. Let's set capital A equal to this sum, 1 over n plus k, as k is going from 1 to the n. Okay, I'm going to use the definition of the integral as the Riemann integral. I'm going to find out the relationship between integral and the limit of this sequence. Okay, so this one equivalent, this is implies the limit of this sequence, 1 over n plus k, as k goes from 1 to the n, as n is approaching to infinity, equal to the integral from 0 to 1 f of x dx. Okay, this is the definition of the integral. This is called the Riemann integral. Okay, so this one, the relationship between integral and the sum of this sequence. Okay, so now I'm going to transfer this one on form of this f of x. Okay, I'm going to transfer this one on the form of the Riemann function. Okay, I'm going to multiply by 1 over n and take it out of this sum, because it's considered as a constant. Okay, so the limit of 1 over n, the sum of 1 over 1 plus k over n, as k goes from 1 to the n, as n is approaching to infinity. Okay, this one is written on this for limit of 1 over n. So this sum, 1 over 1 plus f of k over n. Okay, I'm going to find out the relationship between f of x and this term 1 over n plus k by taking 1 over n outside of this sum, because it's considered as a constant. Okay, so this one implies the limit of 1 over n, the sum of 1 over 1 plus k over n, as k goes from 1 to the n, as n is approaching to infinity. This one equal to this integral. Okay, so equal to 0 1 f of x dx. Okay, so if you take a look at here, this one is the f of k over n. Okay, if we put, let's set f of x equal to x. Okay, if we take f of x equal to x, that's mean this integral, the limit of 1 over n, the sum of 1 over f of k over n. Okay, so that's mean k goes from 1 to the n, as n is approaching to infinity. Okay, equal to this 0 1. This f of x is written of this one dx over 1 plus x. Okay, this one we're just replacing f of k over n by x. Okay, so this one I'm going to evaluate this integral. This integral is simple integral. Just this is the numerator. You can rewrite it on this form. This is 1 plus x prime over 1 plus x dx. This is natural log. Okay, this is integral of the natural log of 1 plus x from 0 to 1. Okay, we don't need the absolute value here, because we know this term is positive. We have a natural log of 2 minus natural log of 1 plus 1, 0, 1, which is natural log of 2. Okay, now we know this into the limit, so that's the limit of this sum 1 over n plus k, as k goes from 1 to the n, as n is approaching to infinity, equal to natural log of 2, which is greater than 2, 1 over 2. Okay? Therefore, the sum of 1 over k plus n, as k goes from 1 to the n, is greater than natural log of 2 and is greater than 1 over 2. Okay? So I have done with this problem. Thank you for watching. I will see you in next video. Bye.